The pair is length matched, the Stackup is unchanged. Yet one production board shows more timing offset than another. If the geometry looks right, the difference may be the local dielectric environment, not the schematic. Stackup models usually assign each dielectric layer a bulk or effective decay. That supports impedance and delay prediction, but it averages the construction. Unless local weave geometry is modeled, it cannot show where a production trace will sit relative to individual bundles. Real laminates contain woven glass bundles and resin-rich regions. A signal is guided by an electromagnetic field distributed between the trace and its reference plane, not by one point directly beneath the copper. The field therefore samples a weighted local mixture, and that mixture can vary across the board. Move the pair sideways, change its angle to the warp and fill directions, or change line width, spacing, coupling, and dielectric height, and the field weighting changes. A route aligned with a bundle may stay biased longer. Angled routing can improve spatial averaging, but it reduces risk rather than guaranteeing cancellation. Even a geometrically matched differential pair cannot place both conductors in the same local field environment. If their fields weight the weave differently over enough electrical length, their effective propagation delay and phase can diverge. One edge then arrives later, creating intra-pair skew despite equal physical length. That intra-pair skew can convert some differential energy into common mode. Local characteristic impedance may also be modulated. Repeating non-uniformity can create reflection or insertion loss features, but this is not the same mechanism as bulk DF or copper roughness conductor loss, and additional loss is not automatic. Production fixes the actual alignment between copper and weave. At another panel location or in a later build, the weave-to-trace registration may be different. The result can vary by channel, panel position, board, or batch, even when the artwork and nominal Stackup values are unchanged. As edge rates and required channel bandwidth increase, smaller local differences consume more of the timing margin. Long routes, weakly coupled pairs, and tight skew budgets deserve more attention in 112 grams or 224 grams channels. But there is no universal data rate threshold, and glass weave does not guarantee failure. Before prototype release, review the longest critical pairs, their angle to warp and fill, trace width, spacing, and coupling, dielectric height, glass style and ply construction, and the actual buildable Stackup. Compare these with the available intra-pair skew margin. Confirm any artwork rotation or material substitution with the fabricator. Then select verification that can observe delay or mode conversion, not only average impedance. The takeaway: review routing, material construction, and Stackup as one system before production release. Explore UltroNiu's high-speed PCB page for manufacturing capabilities and project review.